And welcome to Playing with Symmetry and the 68, 95, 99.7 rule. So here we have lengths of newborn females are normally distributed, keyword here, with mean 49.1 centimeters and standard deviation 1.9 centimeters. So again, our mu is 49.1, our sigma is 1.9. Let's go ahead and draw our diagram, and I'm going to add one more piece to this diagram. So we have our mean in the middle, 49.1. We go up by our standard deviations. Down by our standard deviation. So these were at 51.0 going up, 52.9, and 54.8. Going down, we have 47.2, 45.3, and 43.4. We had our 47 to 51.0. Then our 45.3, 2 hops below, to 52.9, 2 hops above. And then 3 hops below to 3 hops above. So these were all, our 68% was 1 hop to 1 hop above. 95% was 2 hops below to 2 hops above, and 99.7% for 3 hops below to 3 hops above. Now what I'm going to add to this picture is if we draw a line straight through the middle, right through the mean. Because this is symmetric, the distribution, the mean cuts the distribution precisely in half, which means that to the left of the mean, going on forever, and to the right of the mean, going on forever. Both of those account for 50% of the data. So the mean divides the graph directly in half. So 50% of the data should be to the left of the mean, and 50% of the data should be to the right of the mean. More than that, the mean splits each of our regions directly in half. So that 68% region split directly in half would have 34% to the left of the mean and 34% to the right of the mean, etc. So we are going to play around with this. So my first question is, what is the probability that a randomly selected newborn female is between 49.1 and 52.9 centimeters long? So we're looking from 49.1 to 52.9 centimeters. So our mean was at the 49.1. That cuts everything in half. And then stopping at 52.9, that was my blue region. So we are looking at the right half of the blue region. So this is the right half of our 95% region. Again, the brown line, the mean, is cuts each region in half. So if we were looking at the right half of the 95% region, then we are looking at half of 95%, or 95% divided by 2, which is 47.5%, or as a probability, this is 0.475. Next up, let's look at shorter than 47.2. So we are going from 47.2 and looking to the left. So this was just one tick mark below the mean. So we have a couple ways to do this. One way is to know the 47.2 is on that purple region. So this right here is the left half of the 68% region. And then we also, the other information we have is the only thing that goes forever to the left is that brown region we had. So going forever to the left was 50%. So we want this part. We know the entire left half is 50%, and we don't want that purple region. So what we will do is we will do 50% minus the purple region. So we are looking at 50% minus half of 68%, or 50% minus 34%, giving us 16%. So our probability here is 0.16. So anytime we want one side going forever, take advantage of the fact that we can subtract off stuff we don't want from that half. Next up, we have what is the probability that a randomly selected newborn female is longer than 45.3 centimeters? So 45.3 was 2 tick marks below our mean. And we're looking longer than 45.3, so we want this stretch. So again, 45.3 was on our blue region. Our graph is not symmetric, and so anytime we're looking at a region that is not symmetric, take advantage of the fact that the mean cuts things in half and just split that way. So what we're going to do is we're going to use the blue region up to the mean. And then beyond that, because we're going forever, let's use the brown region going forever. So on the left side, we have the left half of the 95% region. And then on the right, we'll just use the entire 50% for the right half of the graph. And we'll just put these together. So we have the left half sorry, we have our half of 95%. Plus that right 50%, or 47.5% plus 50%. And this is 97.5%. So the probability is 0.975. And let's do one more. The last one, we are looking for between 43.4 and 51 centimeters. So 43.4 was 3 hops left of the mean. And 51.0 was 1 hop to the right of the mean. So here's our mean. 43.4 was our corresponded to our green region. 51.0 corresponded to our purple region. So again, we're not symmetric about the mean, so we'll just pay attention to each half. So the left half is our green, or the left chunk is our green. The right side is our purple. We are looking at the left half of the 99.7% and the right half of 68%. So we have half of 99.7% plus half of 68%. So this is 49.85% plus 34%, otherwise known as 83.85%, or a probability of 0.8385. So this is a way we can kind of play around with both symmetry and the 68, 95, 99.7 rule to find probabilities.